Hey everyone, and welcome. Today, we're diving into a piece of tech that, honestly, changed everything about how software gets built and shared. It's called Docker. And it started by tackling one of the most infamous, hair-pulling problems in programming, and turned it into a global standard. So, how did they do it? Let's get into it.
Ah, yes, this phrase. If you've ever written a line of code, you've probably said this or heard it. It's the universal cry of a developer whose perfectly good code suddenly breaks the second it's on someone else's computer. It's not just a professional headache either. It's a massive hurdle for anyone just trying to learn.
So, why does this even happen? Well, it boils down to what we can call the environment conundrum. Every computer is like a unique snowflake. There are these tiny, almost invisible differences, a slightly different operating system version, a library that's a month older, some weird custom setting. And these little things can cause total chaos for software. And that frustration, that's really the core of our story today. It's this deep-seated problem that developers and students have been wrestling with for, well, decades. So much time gets wasted trying to fix these weird environment issues instead of doing the important stuff, building cool things or actually learning computer science.
And when you look at the causes, they seem so simple, right? But the effects are just wild. Maybe your app needs version 2.7 of something, but your colleague's machine has 3.0. Boom, it breaks. Or your Mac handles something a little differently than the Linux server it's supposed to run on. Every single one of these little mismatches is a potential disaster waiting to happen.
And this is where Docker walks onto the stage. The analogy here is just perfect. Docker is like a standardized shipping container, but for your code. Think about it. Before those big metal boxes, loading a ship was a nightmare. But once everything was packed into a standard container, you could put it on any ship, any train, any truck, anywhere in the world. Docker did that exact same thing, but for software. And that standard box is what we call a container. This is the magic right here. A Docker container doesn't just hold your code, it holds everything your code needs to run. The right libraries, the system tools, the settings, the whole shebang. It's a neat, self-contained package. And that guarantees that if it runs on your machine, it's going to run the exact same way everywhere else. That whole "it works on my machine" problem? Gone. Just like that. Okay, to really get this, we need to know the difference between two key terms. First, you have the Docker image. Think of this as the blueprint for a house. It's a read-only template with all the plans and instructions inside. Then you have the container. That's the actual house you build from the blueprint. It's the live, running thing you can actually go inside and interact with. You can build as many identical houses or containers as you want from that one single blueprint.
Now you might be sitting there thinking, hold on, isn't this just a virtual machine? And that is an excellent question. The difference between a container and a VM is absolutely crucial, and it's actually what makes containers so revolutionary. So let's really dig into that.
So here's the fundamental split. A virtual machine, a VM, pretends to be an entire physical computer. It emulates all the hardware and runs its own full-blown guest operating system on top. It's totally machine-centric. Containers, on the other hand, are way smarter and more lightweight. They share the operating system kernel of the computer they're running on. They only need to package up the application itself and its direct dependencies. They're application-centric.
And here's why that difference is a total game changer in the real world. Just look at these numbers. VMs are massive. We're talking gigabytes, and they take minutes to boot up. Containers, they're tiny, measured in megabytes, and they start up in seconds, sometimes even faster. This incredible leap in efficiency, the size, the speed, the low resource use, is what allowed containers to completely reshape the tech world.
Yeah, this wasn't just some small improvement. This efficiency completely upended how the entire tech industry builds and ships software. It really kicked off a new era of speed and agility that we're still riding today.
The real power of Docker is the insane consistency it brings to the whole process. So a developer builds and tweaks their app inside a container on their laptop, then that exact same container gets passed over to an automated system that runs all the tests. And once everything passes, that very same container gets shipped out to the live servers for real people to use. It's one package, one environment from start to finish. No surprises.
Docker basically became the key that unlocked all these modern software practices you hear about. Things like microservices, breaking huge apps into tiny pieces. Docker makes that possible to manage. Automating testing and deployment, or CI/CD, Docker provides the reliable, predictable environment you need for that.
It really is the foundation for how modern, cloud-based apps are built. And the business story behind Docker is just fascinating. The company didn't even start as Docker. It was called .cloud, and they were trying to sell a platform to host apps. But they realized their internal tool for packaging those apps, which was Docker, was way more valuable than their actual product. So they made this absolutely brilliant pivot. They open-sourced Docker, and, like the quote says, they stopped selling a specific car and started building the engine that everyone else could use to power their own cars.
But Docker's impact doesn't stop with big tech companies. In fact, one of the most surprising places it's made a huge difference is somewhere you might not expect: the classroom.
For education, the single biggest win, hands down, is creating a standard environment for every student. A professor can set up a complex programming assignment, package it all into one Docker container, and on day one, every single student gets an identical setup that just works. No more wasting the first week of class just trying to install software. It completely levels the playing field.
And what's really cool is the freedom this gives students. A container is a totally safe, isolated sandbox. Students can mess around, they can experiment, they can break things, they can try to hack the system, all without any fear of damaging their own computers. If you mess up, who cares? Just delete the container and spin up a new one in 5 seconds. It encourages a kind of fearless, hands-on learning that's just fantastic.
So ultimately, this is what it all comes down to in education. Docker gets rid of all the technical friction. It lets teachers teach and students learn. The whole conversation shifts away from, why isn't this installing, and back to where it should be, on the core concepts of computer science. You get to focus on algorithms, on system design, on actually solving problems.
So to sum it all up, Docker's real legacy is that it became this fundamental building block. It gave us that simple, portable, and super efficient unit, the container, that was the missing piece needed to build the massive, complex cloud applications that run our world today. If you want to understand modern software, you really have to start with Docker. And that brings us to one last question to leave you with. Docker absolutely mastered the art of building and running a single container. But what happens when your app isn't just one container? What happens when it's hundreds or even thousands of them all working together across a fleet of servers? How in the world do you manage all that complexity? Well, that's a story for another day.